The solar system started forming around 5 billion years ago out of a cloud of gas and dust called a nebula. This cloud was made of 24% helium and 84% hydrogen. Other gases were nitrogen, oxygen, and carbon. The middle of the cloud's gravity caused the center to become denser and hotter. The cloud's speed increased and flattened into a spinning disk of material and gas. Eventually, the force of gravity pulling gas together and the temperature created enough energy to undergo fusion of hydrogen into helium. Our sun was born. The lighter gas was swept out to the edges of the disk, leaving rockier elements and metals with high melting points nearer to the sun. Dust particles and molten metal formed together to create rocks that were driven together by gravity and eventually formed planets. In the inner region, rocky planets with iron cores were formed. Those rocky planets include Mercury, Venus, Earth, and Mars. This is what the planets look like today, although at that time the planets were hot and had lava consistency, and then they began to cool. In the colder outer regions, the water vapor froze and turned to ice. The ice and metals built up to form the cores of the planets. Then, all the leftover gas that had been swept away were drawn into the cores and created the outer layer of the planets. Thus, we have the gas giants. The gas giants are Jupiter, the largest, Saturn, Uranus, and Neptune. The leftover material formed asteroids and comets that are now orbiting the Sun in belts or just on their own. Earth is one of the rocky planets with a metal core which has 2 layers. The first layer is solid and made of mostly iron and nickel. Those are heavy elements and sink to the center of the Earth, leaving lighter elements such as nitrogen, oxygen, and silicon to rise to the surface. The other layer of the core is made of also iron and nickel, but liquid. The core has a very high temperature, but also very high pressure. Iron is usually a liquid when at such high temperatures, but the pressure of the core allows it to stay solid. Above the core is the mantle, which has a consistency like lava. It behaves like a solid, but over time it can shift and flow. Above the mantle is the crust. It is a solid layer of rock. The crust is broken up into plates that we call tectonic plates that can move over long periods of time due to the flow of the mantle. Here is a video showing how tectonic plates move over time. Where each plate meets, magma from the mantle pushes its way through due to the weaker crust where the plates meet. This forms volcanoes and explains why there are many volcanoes near where the tectonic plates meet. Earth's atmosphere is a layer of gas above the crust. It has 4 layers: the troposphere, stratosphere, mesosphere, and thermosphere. Earth's atmosphere is made up of 78% nitrogen, 21% oxygen, 1% argon, and other gases. A layer of the atmosphere is the layer of ozone, an air molecule that's good at absorbing ultraviolet light. That light could harm things on the Earth, so the ozone layer is critical to the Earth's survival, along with its magnetic field that stops solar wind from eroding away our atmosphere. The magnetic field also traps some of the solar wind and channels it down into the atmosphere, where it slams into air molecules at high speed. That energizes the air molecules, causing them to emit different colors of light. Nitrogen emits red and blue, and oxygen emits red and green. We call this aurora, and it happens near the poles of the Earth where the magnetic field is strongest. The atmosphere exerts a force of up to 1 kilogram per square meter and 10 tons per square kilometer. So about 2 kilograms of weight is pressing down on you and you don't even notice. On Earth, along with its magnetic field and atmosphere, there is one other thing that makes life possible: liquid water on our surface. Most of the water came from when Earth was created, but some came from asteroids that collided with Earth. Carbon dioxide is a gas that makes up only 0.04% of the gas in the atmosphere. It is also critical for Earth because it traps the heat from the sun and doesn't allow it to escape, so it keeps the planet warm. A little carbon dioxide is a good thing, but too much is very dangerous. Since the Industrial Revolution, humans have been putting so much carbon dioxide into our atmosphere, causing it to heat up the Earth, causing ice to melt and sea levels to rise. We need to change our ways to save our amazing Earth that we live on. To go on an interactive tour of our solar system, follow this link.